I'll code now. So over here, my first step would be to sort this nums array, and I create a variable called n that tells me the length of the given array. So I also create a closest sum variable, so which is initially set to nums of 0 plus nums of 1 plus nums of 2. Okay, now I iterate over the nums. So I do for I in 0 to n minus 2. So n minus 2 is not included. Okay, so I do let mutable low is I plus 1, and my high, this should also be mutable, and my high is n minus 1. So I do, while low is less than high, I calculate the current sum, which is nums of I plus nums of low plus nums of high. Following this, I calculate the distances. So I say if the distance of current sum minus target, and I take the absolute value of this, is less than the distance of closest sum that we have stored already from target. So if this condition is true, what we do is we update the closest sum to current sum, and after this we check if my current sum is less than target. In this case, I do low plus equal to 1, and my else if condition would be my current sum is greater than target. So in this case, I do high minus minus. Okay, and my final else case, so I do low incremented by 1 and high decreased by 1, and after coming out from these for loop, I have my answer stored in my closest sum. Okay, so to sort this, I use nums dot sort. Okay, what does this say? So I need to put this as mutable. It says it cannot be updated. So yes, LeetCode 3 sum closest. So I have given an integer array called nums of length n and a target. So I need to find 3 integers that are at distinct indices, and thus their sum is closest to target. Okay, so I have got minus 1, 2, 1 and minus 4. So I need to find 3 numbers at the sum which is closest to target. So over here, my n, that is size of the array, is 4, and my target is given as 1. Since I need to simply return the sum, the relative position of these elements, that is the indices, don't matter. So my step 1 would be to sort these elements. So after sorting, I receive minus 4, minus 1, and then comes 1 and 2. Okay, so I create something called closest. So my closest sum is equal to, I initialize it as nums of 0 plus nums of 1 plus nums of 2. So this is minus 4 plus minus 1 plus 1, which is minus 4. Okay, so this is at index 0, 1, 2, 3. Now I have to start iterating. So I put my I is equal to 0 and something called low, which is I plus 1, and something called high, which is n minus 1. So my n over here is 4. So my I is at this position. So my low would be 0 plus 1, which is 1, and my high would be 3. So I have my low over here and my high over here. So I calculate something called current sum, that is nums of I plus nums of low plus nums of high, which is -4 plus -1 plus 2. Okay, so this turns out to be -5 plus 2, that is -3. So I calculate the distance of current sum and closest sum to target. Okay, so how do I do that? I do closest sum minus target, the mod of this to find the distance, and my current sum minus target, the mod of this to find the distance. My closest sum is initially set to -4 and my target is 1, and my current sum is -3 and my target is 1. We see this distance is 5 and this distance is 4. So we see the distance of current sum from target is closer. So if we have this condition, implies we can update my closest sum to current sum. Okay, so my closest sum has been updated to current sum. So my current sum was -3. Okay, my next step is my current sum, this is -3 and my target is 1. So this is less than target. So what we do is we increment low. So my low moves from -1 to 1, that is index number 1 to 2. So I have my I as 0, low at index number 2 and high at index number 3. So I calculate the current sum again. This turns out to be -4 plus 1 plus 2. So this is -1. Okay, so -1. So I calculate the distance of current sum to the closest sum, to the target, and compare it with the distance of closest sum to target. So I do closest sum minus target and then current sum minus target. Okay, and I find the distance of this. So my closest sum is initially set is now -3 and my current sum is -1, and from the distance of these from 1. Okay, the distance of this being 4 and the distance of this being 2. So I see my current sum, the current sum is more close to target. So if I have this condition, then I do my closest sum is updated to current sum. Okay, so my closest sum goes to my current sum, which is -1 in this case. Now my current sum, which is -1, and my target is 1, this is less than this. So I do low plus plus. So when I move this low from index number 2 to index number 3, it is equal to high. So this is not feasible. So now my task is to increment I. So I have -4, -1, 1 and 2. So now I increment I. So this is 0, 1, 2, 3. So my I is 1, my low is I plus 1, high is n minus 1. So this is 2 and this is 3. So my I is over here, low is over here, high is over here. So my current sum is equal to nums of I plus nums of low plus nums of high. So this is -1 plus 1 plus 2. So this turns out to be 2. Now I calculate the distance of current sum to target and compare it with the distance of closest sum to target. So I have current sum minus target and I have closest sum minus target. Okay, so the target is 1 in both the cases. One minute. Yeah, so my closest sum has been updated to -1. Okay, so I have -1 over here and my current sum, this is 2. So this is at a distance of 1 and this is at a distance of 2. So if this condition is satisfied, so yeah, if this condition is satisfied, I update my closest to current. So my closest sum goes to current sum, which is 2. So this is 2. Now I check for current sum. So my current sum is 2 and my target is 1. Sorry. So this is greater than target. What I do is high minus minus. So when I reduce the value of index high, it goes over L. So this is not possible. Now I have to increment I. One thing to notice is I started from I over here. Then I moved to I here. Now I am at I at index number 2, but I won't be able to find 3 elements. Therefore, my I goes from 0 to n minus 3, inclusive of n minus 3. Okay. Now I will code in Rust.